Hey, how's it going, everyone? Max here. Gonna go over P2A real quick. I should have done this a couple days ago, but my group office hours were canceled for that, so I wanted to go ahead and make it up to you guys and just go ahead and record this quick 15-minute video or so, just going over P2A, some common issues students have, and also just like the process you go through for solving this. So what we're doing here is we're taking our existing assembler from project 1A. So basically, you can literally copy and paste your code from P1A. That's a really good starting spot for this project. And we're creating this new assembler. The big difference here is we're introducing these things called global labels. So a global label is going to be defined by any label that starts with a capital letter. So in this example right here, we can see that subadder is indeed a global label, whereas these other labels are still local because they're in lowercase. So a couple things about global labels. They don't have to be defined in a given file. So let's go ahead and just look at example one real quick. We can see that subadder is referenced by this load word instruction on this line. But the thing is that subadder is actually not defined in this file. That's completely fine. What you should be looking for is essentially if a global label is referenced by a load word or store word instruction, but it isn't defined, that's not going to be an error in this case. What is going to be an error is if we have a local label like 5, for example, that isn't defined within this file. So just like project 1A, we still need to error check for that. What we want to do, though, is make sure to keep track of all of our global labels. So again, for example, we have subadder right here. This is going to be a global label. We want to keep track of that. The objective of the project is to basically, whenever you assemble a file, the output's going to be a bit different. That's because we want to go ahead and make sure that we can use it with our linker for project 2L. So what does our actual assembly file output look like? Well, we first have this header right here. The header is basically going to be composed of 4 things. It's going to be the size of text, the size of data, size of our relocation table, and the size of our, sorry, this should be symbol table, and the size of our relocation table. When I say size, it's basically how many entries do we have in here. So what I recommend doing is having just 4 variables dedicated to keeping track of how large these sections are. So whenever you do your first pass, you can go ahead and just determine, cool, this is an opcode that isn't fill. That means it's going to be an instruction. And as we talked about in discussion, instructions are all located inside text. If it's a .fill statement, then it's going to be data. And then symbol tables and relocation tables, we have to go ahead and construct those. So right here, what we can see is that we have 1, 2, 3, 4, 5, 6 items in text. So we'll go ahead and put a 6 here. Our data is going to be just size 1, so we'll put a 1 here. And then we'll go into seeing what our symbol tables and relocation tables should be. A couple notes, though, on what global addresses actually mean. So again, a global label is just a label that has an uppercase for its first character. And what that allows us to do is whenever we link up files, this subadder might be defined as some other file, which it is right here. So essentially, load word would go ahead and it would pull the value of sub1 right here and put it inside register 4. That's what happens in the linker. For P1A, sorry, P2A, we're actually not concerned with that. All we're concerned about is resolving this address. So if you ever see a global label that isn't defined within your file, check for 2 things. First of all, if it isn't defined, make sure you're not working on a BEQ statement. If a BEQ statement references a global label like this that isn't defined within its file, then that's going to be an error. The reason being is that BEQ uses a PC relative for its offset. And if we do have a global label, that could cause some issues. However, if the global label is defined within the assembly file, so let's say, for example, this is a global label right here, this is fine. As long as the global label is defined within this file right here, we can have that as input. What we can't have, though, is, let's go ahead, change this back. Let's go ahead and add this label right here. We'll call it global. And let's say that BEQ is going to global, like this. Since global is not defined within this file, we would have to go ahead and exit 1 on that. All right, cool. So the first thing we'll do here is go ahead and translate our text section real quick. So what we're going to do next is go ahead and translate our text into machine code. So for this instruction right here, this is the exact same as you do for project 1A. So I'll go ahead and copy this in real quick. So we have this right here. Next thing we have is this load word instruction with 04. But right here, we have a global address. So what we do is we actually resolve this at the value of 0 because it isn't defined within this file. So if you go ahead and translate that over, it's just going to be the opcode load word. Reg A is going to be 0, reg B is going to be 4, and then subadder, that address is going to be 0. So we have this. Next thing we have is adult. So these three statements right here won't change at all. They're going to be the exact same as they would be in project 1A. So is halt. I'll go ahead and put that in real quick. All right. Next thing we have is our symbol table. So a symbol table essentially references symbols that are used within this file. You only need to include one symbol once. So what we're first going to do is find any defined symbols within this file. So a defined symbol, again, is just going to be a global label that's defined. And again, a definition, a label being defined is if it's referenced on the left-hand side of an opcode like this. So for example, in example 2 right here, we can see subadders defined on this line right here. If it isn't defined, we'll go ahead and include, and it's referenced, we'll go ahead and include that as well in our symbol table. So the way we do this is we'll go ahead and first put the label name, so subadder, because that's going to be a global label. So we'll say subadder, and then we'll say, is it defined in our data section, our text section, or is it undefined? So since this isn't defined anywhere, we're going to go ahead and say it's undefined, and then the line number it's at if it is defined. If it's undefined, we're going to go ahead and put 0 right here. So what happens if it is defined? Well, in this case, what we'll do is we'll go ahead and say, for subadder, where is this defined? In this example, subadder is going to be defined. We'll go ahead and say subadder. It's defined in the data section because there's a fill statement associated with it. So we'll say data, and then what line of the data section is it defined in? So if we say this is line 0, then subadder is going to be defined on line 1, just like this. So going back to this, since this is the only global label we have, we're done with the symbol table. So we'll go ahead and put a size of 1 right here. After that, we have our relocation table. This is essentially dedicated for load word and store word instructions that reference labels. Because once we're done linking, once you start doing the linking project, you're going to begin to realize that if we reference, let's say, for example, 5 and subadder, those are going to shift around with what line they are in our file. Because once we link, our text sections and data sections are going to be stacked on top of each other. So the line number in which these labels are defined is actually going to change. So we have to keep track of that. So in that case, we can see that load word references 5. So for our relocation table, the way we record entries is if we go ahead and specify what line does this occur at. So this occurs at line 0. What instruction is it associated with? Load word, and what's the label? 5. So even though this is a local label, we still have to do this. And again, the reason why is because once we link, we're going to have essentially the text of our first file right here, the text of our first file right here, the data for our 0th file, and the data for our first file. So as you can see, that's basically going to go ahead and change what line number they're defined at. And if we go ahead and just resolve load word 5 to basically be the offset of 1, 2, 3, 4, 5, 6, that's going to end up changing. So by keeping track of this information, we can go ahead and just add some value onto this offset, and then it's going to be properly linked in the future. And again, we're doing this because where these labels are defined is going to change once we link up. So again, we have to go ahead and do the exact same thing for this right here. So local labels and global labels for load word and store word, we do have to do this for. So I'll go ahead and say line 1, load word, and subadder. Now you might be tempted to go ahead and do this for the BEQ statements, but we actually don't have to do that. The reason why is because BEQ statements are going to reference a label local to this file. And since BEQ statements use PC relative addressing, if we go ahead and let's say this text section for this file right here ends up getting moved around, that's not going to be an issue. The reason being is that, again, we use PC relative addressing. So this start right here will basically say, go backwards 2 steps. That's not going to change if we go ahead and move this text around. It's still going to be the exact same. So we don't have to go ahead and change that at all. And since this is it, we're going to go ahead and say this is of size 2. And that's going to be the output for the first example. Second example is going to be a very similar process. So we have load word 0, neg 1. We go ahead and just do that is the exact same as we did for project 1A. Go ahead and put this in here like this. Next 2 lines are literally the exact same thing, which is pretty cool. Oh, I did not do the fill statements. Sorry about that. I just realized that. Okay. We also have our data section. We'll just put a 5 right here. All good. Going back to this, we do have 2 of these values right here. So we do have a fill statement of -1 and sub1. We're then going to go ahead and say -1 for data, -1, sub1 is defined at line 0. We'll go ahead and put that. For our symbol table, it's going to be a very similar process. So do we have any global labels that are defined here? We do have subadder. It is defined, so we'll go ahead and say subadder. It's defined on int data, right? Because this is associated with the .fill statement. So this is our data section, and it's defined on line 0, 1 of our data section. So go ahead and put a 1 right there. And that's it for global labels. Last thing we have to do is our relocation table. So relocation table, again, we're going to go ahead and look at our load word operators, store word, etc., and any fill statements that are dependent upon opcodes, dependent upon a label's value. Because again, notice here, we're filling it with whatever line that sub1's defined at. So in this case, we said 0, but once we do end up doing the linking process, again, what's going to happen is we're going to have our text from file 1 up here, and then right below that is going to be the text from file 2. And that's going to change what line sub1's defined at. So once we do the linking process, what this looks like is we have all these opcodes right here. I'm going to copy this, put it down here. Whoops, 1 second. All right, so when we link this up, what we actually have is we have this text section right here, and then we have the text section of this next file right below here. So notice here that sub1, its address, like the line it's defined at, is actually going to change. It's now going to be 1, 2, 3, 4. It's going to be, sorry, 0, 1, 2, 3, 4. It's going to be 6 now. So it's going to end up changing the value of the .fill statement right here for .fill sub1. So we have to go ahead and put that inside a relocation table. And as always, we have a load word right here, which is dependent upon this label, which again is going to shift after linking. So I'll go ahead and put that in right here. I'll say on line 0 is where it's defined at again, load word, and then the label is dependent on -1. We also have to go ahead and do the exact same thing for the fill statement. So we're going to go ahead and say 1.fill, because this is defined in line 1 of the data section. And we'll just go ahead and say sub1, just like this. And the cool thing is we know that this is inside the data section because it's a fill statement. If it's a load word or store word, then it's going to be dependent upon the text section. And after that, we'll go ahead and say we have 3 entries for our text section, 2 for our data, 1 for our relocation, or 1 for our simple table, and 2 for the relocation table. A couple of quick things to summarize here before I sign off real quick. Main thing being is recognize this. BEQ does not need to be updated. Its entries don't need to be added to the relocation table at all. Again, that's because they're PC relative addresses. So that means, it's already resolved. Whenever we link up the files, it actually won't change anything at all. So don't add those in. If you do, you won't get it right, unfortunately. What else is there? Oh yeah, BEQ, it's totally fine if it references a global label. Just make sure that it's defined in that file. So right here, if I added in some line like BEQ 0, 0 subadder, that's totally fine because subadder is defined within this file. Notice here it's defined in the fill statement, so that actually would break our program. But if I move this to say right here, subadder like this, then move this out of here, then that's fine, right? That makes sense. Besides that, a couple other issues I've seen students have is whenever you're creating a file, just make sure that you aren't going over the label limit in terms of its size. I've seen people with labels that are size 7 or larger in terms of character count. Just make sure you're not doing that. Also, make sure that you are using registers that are between 0 and 7. So just look at that before you submit it. I'm going to think of some more issues and I'll just come back real quick. All right, I can't think of any more issues people are having, like any glaring issues. But one thing I can say about the process is if you were to go ahead and work on example 1 real quick, just like as a computer, like how do we think about doing this? You still want to do your first pass, go ahead and create the label map you use in project 1. Store these labels. You still want to make sure that if the label is being referenced, it exists if it's a local label. If it's a global, you can tell it's global again, because if its first index is a uppercase letter, so you can go ahead and look at the ASCII value or just say, oh, is a value between capital A and lowercase and uppercase C. If it is, then it's a global label. So be sure to check that. Once you do that, I recommend just translating your text instructions. Again, it should be literally the exact same thing you did in project 1A. The only difference being that load word and store word, if it's a global label that's not defined, then you just go ahead and put a 0 for the offset. After that, go ahead and look at your symbol table, then relocation table, keep track of that information, and then at the very end, go ahead and print everything out. That is because the first thing you print out is going to be the header, and you won't know the size of the information until you're done with your program. So let's go ahead and have like 4 counts for those, print it out, then print out your text section, then your data section, relocation table, and then your symbol table, then relocation table. Otherwise, the project shouldn't be that much extra work. Again, use your code from P2A. You should be chilling, and come to office hours if you have any questions. I know it's due in 2 days, so they'll be kind of busy, but hopefully we can try to get you in, answer any questions. Piazza has a lot of good answers on it right now, a lot of good questions, so be sure to search there as well. Should be able to find something pretty fun there. And yeah, besides that, leave any comments, get any questions about what I talked about today. Hopefully that was useful to you guys. Yeah, let me know if you have any more questions, and yeah, good luck.